The third representation is by table. This stuff is not very important anyway, but still. By table. So here I have what? 1, I'll use red. 1. So here's my x, here's my y. X is 1, 2, 5, and pi. Y is what? 1 go with 4, 3, 2 go with 4, 5 go with 6, pi go with e. In discrete math, you see this a lot when we talk about function and whatnot. For our class, you see these two. All right, now function is a subset of relation. Any function is a relation, but not all relation are function. Why? Because that's a restriction. Now, I define the relation is a set of x and y. That's it, right? You have an x and you have an y. I don't care what is x and what is y. However, function a bit more pickier. A function is a relation that assigns each element in its domain exactly one element in the range. So all that formal definition, this means x cannot be repeated. That's what it meant. Cannot be repeated, right? If x repeated, it is not a function. It could be a relation, but it's not a function. So x is, we call that's the independent variable, right? Independent. Sorry, this is boring because it's all like bookkeeping here. Independent variable. And y is the dependent. Makes sense, right? You can choose x anything you want. Literally anything you want. But when you put in a function, then y depend on x, right? Whatever x is, y take x characteristic. All right, how about you guys tell me, is 1 is a function? First of all, is it a relation? Is it a relation? Is this a relation? 1. Yes, right. Is you have x, y. That's it. That's all you need. You have x, you have y, and they go together. Is it a function? Yes. Yes. Because x is not repeated. You have C 1, 2, and 3. So you okay? So yes, it's a function. Yes. What about number 2? Because what repeat? Which one repeated? 1. Right? 1. No, because x is repeated. And I'll highlight that. That'll be number 1. Can y be repeated? Sure, right? I can have something like this. You don't have to write this down. I can have 1, 2, and then I have 3, 2, 4, 2. As long as my x is not repeated, y I don't care. It can be repeated, right? Because why? Because the function is assign each element in its domain exactly one element in the range. I know this formal definition is kind of confusing. That's why I never test you on theory. On your exam will be all problems. Kind of similar to what I'm doing right here. What about number 3? So number 3 is a function. This would be more abstract. They don't give you the points. Right? As long as you don't pick x repeated, right? So let's see. What can I do? I can graph it. Let's graph this. I'll do this by hand first. I'll do the 4th and the 5th one. I'll do by use decimals. So I'm gonna this one I'm gonna do by hand. It's not too bad. I wish I should have leave a little bit more space. Oh. Okay. Someone pick me a value for x. When x is 0, y is 7, right? When x is 0, y is 7. So I'm just gonna say 7 is right here. 7 is right here. You're supposed to have a little arrow. I don't have enough space. When x is 1, y is what? When x is 1, what's y equal? 5, right? You can do it in your head. 5. You guys are not 661 anymore, so I don't write it out. 1 and 5. Say 5 is here. When x is 2, y is 3, right? 3. Okay. All right. So basically, it's a line, right? It's a line. If you connect those dots, these are line. Do you think x repeated? No, right? No. Every x is not repeated. We're gonna talk about this later, but I'm just gonna give you a little preview. If you draw a vertical line, to the red graph, as long as the vertical line cut the graph only once, then that's its a function. If it cuts 2, then it's what? I mean, your x repeated, right? Because, so for example, if I have something like this, don't write this down. No, I don't want to write. I don't have space. If I have something like this, stinky. It might. It's stinky too. For example, I have a smiley face. Is it a function?
No.
No, right? If you draw a vertical line, it's cut twice. So that means for you have 2x, but how many y? 1 y here, right? 2x equal. Right. Anyway, that's for 3.6. So yes, it is a function. What about number 4? Y equal x squared plus 1. I'm gonna use decimals. Do you guys know decimal? Have you? Anybody mention you decimal? I know the high school teacher use this a lot. It's great app. Y equal x squared plus, is a plus 1? Plus 1. It's a parabola. It's a parabola. It's called that shape, that little curvy V shape is. It's not quite V because the bottom is kind of curvy. It's a parabola. So let's pick a few points. Say x equals 0, y is 1, right? X equal 2. Come on. I'll pick it right here. Never mind. I'll pick it right here. X equal 2. Y is what? What is y? I think it's also, if x equal 2, y is 5. Right there, right? So every x that you pick, you only see 1 y. See 1 y. Or you do a vertical line, you can only cut it once. So let me draw it here real quick. Look like that. I know it's not symmetric, but something like that. So you say yes. What about 5? 5. X plus y squared equal 3. Try this here again. You can tell me right away. This x plus y squared equal 3. What do you think? Let me mute that one. Is it a function? Is it a function? No, right? You see, let's see. If I pick 0, it gives you, yeah, 0 comma, yeah. How about this? -1, -1 comma 2, and -1 comma -2, right? So x repeated it. So no, I'm not going to write it. I will draw it. No, not a function. So that's okay. Pretty simple. Now the thing that you're gonna see on the exam, evaluating the function. So I give you a function and I want you to evaluate it. Remember, x is your dependent variable, right? So wherever, if I say f of x, then your input will be something squared, that something now is x, right? 2 times something more, something now is x. What about f of 0? What f of 0 mean? 0 what? I think I understand what you mean, but I want you to say it. Yeah, actually, I mean x equals 0, right? So this imply, thank you both. This imply x equals 0. So all you have to do is replace x by 0, right? So the function is I have, so this equal of, if I was you, I would do this. Something, I replace what x with the parentheses. So parentheses square plus 2 square. Because later it's going to get more complicated. I can give you, instead of 0, I can give you x plus 2. Yeah, something more complicated, right? All right, so now replace x with 0, 0, which is equal to 0, right? So f of 0 is 0. F of 3, this imply you replace x with 3. So equal something square plus 2 times something, and that something now is 3. Good, thank you very much. 15. F of A. Yeah, that's it. That's it. So A and A. We box the answer. F of negative x. What do you think? Someone tell me the answer. Careful, careful. Negative x is being in parentheses, so that's mean what? Yeah, so this imply I have negative x times negative x, which is positive what? X squared, right? Positive x squared. That's why I use a parenthesis. On the exam, it's I see it is a very classic mistake. Don't write this down. A lot of people will do this. They use the negative x squared plus 2 times negative x. That's what they do that, right? It's students, they do that. And then they forget, oh, negative x squared is negative x squared. And then 2 times negative x is negative 2x, which is wrong, right? Oh, thank you. He actually kept his word. He worked, so I had to accommodate him. I'm very flexible. I don't care how you study, as long as you study. Well, attend my lecture. I don't want to be here alone. And you pay for it, of course. You take everything out of me, right? But yeah, I'm very flexible in terms of how you study. So x squared minus 2x. What is the little vertical here mean? Yeah, absolute value. So absolute value means what? What's does anybody remember the definition of absolute value?
It doesn't matter if it's negative or
Yeah, it's the distance, right? And distance cannot be negative. Any number you put into that little 2 vertical bars, they turn out positive, right? Because it's the distance from 0. You don't say I'm running negative 2 miles, right? All right, so h of negative 2. So this means what? You replace x with negative 2. So this is something, the absolute value of something over, I write large. Let me write a little smaller. Equal negative absolute value of something over something. So that'll be what? -2 over -2. Absolute value of -2 is 2, right? Thank you. And then -2 in the bottom, it still stay -2, so -1. H of 2, what's the answer? You can do it in your head. 1. Right. So this imply equal absolute value of 2 over 2, which is 2 over 2, which is 1. You gotta try number 3. We almost done. It's not too bad. Let's see. Tried to find a video for you, couldn't find it. What you got?
If you sort of set it up.
Oh.
Yeah.
Oh, you just replace y with no. H of -4. So inside the parentheses, that's the one that you replace with the letter.
So the equations for the.
The equation is 3 times absolute value of 1 minus 3, minus 1 minus 3. And you're supposed to replace -4 for y. I can write, yeah, I can use any letter I want, right? Excuse me. Yeah, I can't find the videos. Does anyone want to take statistics in the future? Stat statistic. You taking it?
No, I haven't taken it.
But you are.
Yeah.
You too, Devin? Yeah. Yeah, my specialty is statistics. They just make me teach math because they're more math classes than stat classes. But I always been teach statistics. My degree is statistics. Okay, what you got beside Devin? -18. Okay, and 12, and then who else? 12. 12. Okay. Oh, I'm so sorry. Maybe we have 12 as a winner. Okay, so why? So this, yeah, this imply replace y with -4, right? So equal 3 absolute value, and I'm gonna whenever I see a letter, I replace by parentheses. You never get it wrong, right? You see a letter, you replace with parentheses. -1 absolute value -3, And then the parenthesis gonna replace with, you know, put in -4 inside the parenthesis. Inside first, right? So -4 minus 1 is what? -5, right? Well, absolute value of -5 is +5. 3 times 5 is 15, minus 3 is 12. Hi, Kevin. I'm glad you're kept your word and actually turn on your getting your Zoom. Appreciate it. Well, again, I messed up my my session, so my dog is here. It's supposed to be yesterday. There's Aaron again, having full coma. All right, last one, and then we'll be done. Domain of the function. Domain of a function, like we said, is a set of x number. Is the set of is what is the set of all real x values. Yeah, for which y is defined. What does that mean? Why does it say? Well, you know the domain is all x values, right? That's not new. It's kind of similar to the relation, but because it's a function, we talk about function. A function has to be defined, right? So you only allowed to pick some x that make the function defined, which I'm going to explain it to you. Some type certain function that have certain value that make it undefined. So the range of the function is the set of all real y values. So if I was you, I would think x as my input or the width in terms of geometric speaking. If I graph it on Cartesian coordinate, I think of my x is as the width. I want you to think of the range is your output. If in geometric sense is the height. So for example, I have f of x equal 5x squared plus 4. I want you to find the domain and range. If I was you, I would graph it first. I think I'm going to show you how to graph it on graphing calculator. For this one, right? So you go to y equal. Do we have it? No. Does anyone have graphing calculator inside? Right, everyone know? No. I wonder if should I. Darn it! It's make it difficult for me to, because I know the department don't let you to use it, but it's my class. How about this on the exam? I'm just gonna show it now. If you have one, you can borrow one from the department. On the exam, I'm just gonna give you the graph. Okay, so people that don't have the graphing calculator is not gonna freak out. So graphing calculator, in order to graph that function, I want you to go to y equal. You guys see the y equal on top here? Y equal there. So y equal, and then plug in your function. Can you tell me the function, Mike? Was it 5x squared?
Yeah, 5x squared plus 4.
Yeah. 5x squared. Do you guys know how to do that, or you have to show you step by step? 5x squared. Oh, here. So when you go to y equal, number 5 is easy, right? Just number 5. What about x? X will be this one, right? X will be that one. X, t, theta, and n. And then square, just press that button. You see. So 5x squared plus 1. Plus 4, thank you. Plus 4. And then graph. See on the right, upper right. What we're gonna do zoom 6. So zoom 6 will give you a very a standard window. So zoom 6, maybe zoom 0. Yeah, zoom 0 is fine. Zoom 6, zoom 6, zoom 6 better. Zoom 6, right there. Okay, so if I look at this graph, you know what I'm gonna do? I'm gonna use decimal, so you can see better. There you go. Remember, your domain is all the x values, all the width. Now this graph is gonna go out forever and forever. It's gonna get larger and larger. If you project this down on the x-axis, what do you see? So just say from the left. I start from the left. I project it down. Do I have x value? Do I have x value? Imagine that's gonna go out, like extend it out to infinity, right? Do I have x value all the way to negative infinity? Yes, right, yes. You don't see it, but anytime you project the red, pick a point on that red graph, project it down on the x-axis, you always get an x value. I put that part. Same thing on the right side. Do I have an x value all the way to the positive infinity? Yes, right. All you do is pick a point on that graph, on the red graph, project it down on the x-axis. As long as you have it, that's your domain. But remember, domain is the width. So the domain here will be what? From everything, right? Negative infinity to positive infinity, right? You can pick any x you want, any x you want. What about the range? Remember, the range is the height. So where does the graph start? Where does it end? Yeah, it starts at 4, right? So it starts at 4 because you don't have anything below 4, you don't have it. And then go to, yeah, go to positive infinity, right? Because same thing, I don't bore you, but anytime you pick a point from the red graph, project it over the y-axis. If you have a y value, that's your range. So the width is everything, right? So the graph gonna get wider and wider. I'm gonna graph it for you. On the exam, I'll give you the graph. But you have to tell me what the range domain. Right? For okay, so the domain is everything. If you want to give me R script, that's fine too. If someone give me that answer, I'll take that also as well. Unless I specify in what is that in interval notation. The range will be, so how would I write in interval notation?
Bracket for
Yeah. F of x equal 1 over 3x minus 6. And I don't feel like plotting them by hand. So I'm gonna use decimal again. Decimal is awesome. I don't know about you, but it's awesome. 1 divided by, what was it, Devin? Thank you, 3x minus 6. Where is it? Oh, I haven't, I muted it. Come on, where is it? Oh, right there. Now let's talk about the width, the domain. What do you think? Start from the left. You always go from left to right, bottom up. So left to right. Do I have an x value at negative infinity? Yes, right. Just pick one and hope it go out wherever to the left. What happened here? As I get closer and closer to 2, what happened? Closer, closer, closer to 2, what happened? Yeah, it shot down to negative infinity. Well, you don't see it, but it's actually, this red graph never touched 2. Right? So I get very close to 2 from the left, but I never touch 2. So this means what? 2 is not. negative infinity up to 2. What about the right? I start from 2. Do I have 2 from the right?
No.
Yeah, it's the same thing, right? I get closer to 2 to the right. The graph shoot up to positive infinity. Of course, it never plus 2, but as I go further and further to the right, I have x again, right? So the domain will be from, someone want to tell me what the domain is? From 2 to to 2, yeah. So 1, 2, where's my 2 there? So I have something like this. I know it looks like touching, but not supposed to. And then it does like this. Right. Oops. Damn it. Huh?
On the test, are we gonna have to plug in different values of X, or is there gonna be
No,
like?
no, you shouldn't. You can try it out. You can try, but I'm not asking you to plug in values because you have infinite many values to plug in, right? Yeah. But you can try it out. It's a good thing. It's a good thing you tried out some values. But I'm gonna give you a graph, and you're supposed to tell me. So these two right here, they call the vertical asymptote. That means the graph never touch it. Never, ever. So so the domain, someone tell me what's the domain in interval notation? Oh, so we have negative infinity. We do have that. To what? To 2, right? To 2. Yeah, but we don't include 2. So if we don't include 2, what do we use? Yeah, parentheses. Yeah, parentheses. So I know it looked like we include 2 because the parentheses imply that we don't include 2. Union. What now? To, yeah, to infinity. That's it. One thing at a time. Yeah, don't think too. A lot of times people try to solve everything at once, and that make it difficult. So just do one thing at a time. What about the range? The range, let's do from the bottom up. The bottom. It's not supposed to touch. Okay, I'm so sorry. It's not supposed to touch. It's not supposed to touch. So it go from, do I have negative infinity?
Yeah.
Yes, right? Project over, I do always on it. But when I go to up to 0, what happens?
It doesn't touch.
It doesn't touch, right? It doesn't touch. So at 0, it's on the x-axis, and the red one does not touch. So you never touch the red one when you project it over. So we go from negative infinity up to 0. Adding to 0. And what about the upper part? I had positive, the same, right? I say from 0 to positive infinity. So negative infinity to 0, up to 0, union 0 to positive infinity. You guys tried the last one. I'm gonna graph it for you. So let me see. Cube root of x. What was it? I forget things like instantly. X minus a. Just froze on me. Y equal cube root. Where do I go for cube root? Let me see. Where do I go for cube roots? I see square root. Is it 3? No. Oh. Function. Here we go. Function. You guys. Oh, right here, and root. So 3. And then x minus 3. Minus 8. Right there, that's your graph. The reason you see the 8 there, if you plug in x equal 8, what happens? 8 minus 8, 0, right? Cube root is 0, 0. It's at 8, no height. Right? Squash to 0. So what do you think? Let me graph it for you and you tell me. I'll give you time. You tell me. Look at what it look like. He is 8, by the way. All right, and I'll give you a little bit. Kevin, if you want to put your answer in the chat. My picture might be a little bit messy. I'll fix it again, but. Almost correct. You get half correct. Oh, if you just read it again, you have a mistake. No, no. Very good. Domain correct. Correct domain. Not ready. Alright. Oh, domain.
I guess range. That looks like it goes up though.
Yeah, it go up. Yeah, that's why I say my grab a little bit deceiving. Good.
I did.
Correct. Good domain. That's okay. One. Let me redraw my graph. I apologize. Maybe I'll do it like this. Better. Okay, so the domain, everybody got negative infinity to positive infinity. Yes. The range again, bottom top. Better right now. So what? You tell me, what is it?
So actually, it's like infinity.
Same thing, right? Same thing. Because every time you pick a point on the red one, project over the y-axis, you have it, right? You have it. So and of course this one to go down forever and forever. That's go up forever, forever. Yeah. Sorry, my graph a little. Yeah, on the exam would be better because it's gonna be computer.
So it's
Do
just
the
the same thing as the main.
Yeah. Yay, we right on time. Done. I like 1 hour class because guess what? How long is the human attention span? Guess it. Guess the number. Do you think how long we can focus? Oh, that's long. Let's look it up. Let me allow me to.